some exponent rules here. Because the whole first half of this chapter is based upon working with these rules. So let's review them real quick. If I have the same base raised to different exponents, and I'm multiplying them together, what do I do to my exponents? I add them. Good. This would equal a to the m plus n. If I have the same, if I have a base raised to a power, I multiply them. Okay? When I'm dividing out, what do?
Game of war.
We subtract. Yeah, we play that game of war. Now, when we did that game of war, we alleviated the whole idea of wanting the negative exponents just by moving things who wins, that whole thing. So here we would just say, play war. Now, if something is negative, what happens?
1 over.
Good. It's not happy in the side that it's in. So it becomes 1 over that. Now, if it's unhappy in the denominator, bless you, where does it become happy? In the top. Good. All right. Funny you mentioned that. Here's the question I want to look at. Yeah, somebody told me that I accidentally hit the wrong button. I totally forgot to change that. Now, what's going on here is that you have to remember what the exponent rules meant for nth roots. Now, if you have the nth root of something, that becomes what? Good. A to the 1 over n. All right. And also, the trick that we did with these, not fractions, but the trick we did with the variables with the nth root was what? Exactly. We're dividing. We're doing quick division. Now, when I get to a problem like this, what's the very first thing I'm going to do? Move z up. Good. I move z up just by using my exponent rules. Now we have a whole bunch of happy exponents, right? Okay. All right, hold on a second, man. Is everybody okay with that? With happy little exponents?
Yes.
All right. It's a Bob Ross reference. So 7 goes into 16.
Twice. It's
How many?
left over. I know what I'm doing.
Then show us.
Oh. Never mind.
No, it's okay. I know she knows what she's doing.
For one.
So 7 goes into 16 twice, so 2 can come out, and 2 have to stay in because there's still a remainder. You okay with that?
Yeah.
So there's still going to be a 7th root here. All right. Now 7 goes into 22 how many times? 3 with 1 left over. So 3 come out, 1 stays in.
Pretty easy, actually.
7 goes into 35 how many times? 5 times.
With none left.
With none left over. Now, did this problem start as an nth root or a fractional exponent? So do I leave it as an nth root or a fractional exponent?
Leave it.
You're done. That was one of the questions. Yes, ma'am. Yeah.
On the test.
I'm getting there. I'm getting there. Okay. Who's the other one? Yes, yeah.
Test. Maddie. You can read. Oh no, that's what I messed up. Left it is like 20. I left it as like 25 to the half hour. 25.
So if I'm looking at this, do those have the same base?
Yeah.
Are they raised to different exponents?
Yeah.
What do you do?
You gotta make that bottom one.
You
Play war.
Oh, play
You play war. It's division, right? Which means you have to get, in order to be able to play war here, you have to have a common denominator. So if I'm looking at 1/6 and 2/3, it becomes 4/6. 4/6.
I can't say.
I can't do that either.
4/6.
Say 3 times fast.
My front teeth are fake, so it's tough for me to.
Wait, is it really?
Yeah.
What happened?
Broke them from the what?
Road wedding.
No.
You used to roll.
I used to rollerblade. No, it was, I fell down a flight of stairs in kindergarten, and it was I hit my face on the metal railing.
Oh, I fell off the stairs.
What's that? Yeah. I already had my front 2 teeth in kindergarten. Yeah. Yeah, they're like half fake, so. It's enough of that. This is surprising. So are we okay if I just do this?
Yeah.
All right. So now we play the game of war. Who wins? The bottom. So it winds up with, excuse me, 1/25 to the 3/6, which is
The 1/2, which is fun. Oh my god.
What is the square root?
1/5.
Five.
Wait, did I?
I almost got it, but I didn't do it that way.
Does that make sense how I set that up?
Yeah.
I'm pretty
That
sure
was
I
the
got
reason
that
I got
right.
that wrong.
What happens here a lot of times is you guys climbed up. You didn't trust the fact that you remembered the simple exponent rules. All it was playing war. Play war, work yourself slowly through it. I made sure that the fractions weren't going to be anything that was going to be astronomically scary. 2/3 to a 1/6, that should have been somewhat pleasant. Yes, sir. What we're doing is we're playing war here. Remember when you had x to the 3rd over x to the 6th? Who wins? It wound up being 1/x to the 3rd. I'm doing the exact same thing, but instead of it being an x, it's a 25.
Okay.
And I have fractional exponents as opposed to integers. All right? Yeah.
Could you go over like a problem where something to a negative fraction, like 60?
I'll get there. I'll get there. All right? Let's see here.
That's just hard to write. It's like,
Yes. Yeah, this was on there. Okay.
yeah, like,
Now, couple things you got to set up with here. Guys, you can't simplify anything between the numerator and the denominator right off the bat because you have the numerator raised to a power, which means you have to distribute that power to both exponents. You have to do that first. All we're doing is order of ops here.
I don't think I like the word order.
All right. The operations within the order. PEMDAS, there we go. So this becomes x to the negative 3/2 y to the negative 9/4 over x to the 3/2 y to the 3rd. I know she thought it was hysterical, so she snorted. We got it on tape. Mark it. What time is that at? Everybody need a ringtone? Right about 10 minutes into the tape today, we hear up.
We should play it back again.
I'm sorry. That was awesome. That'd be a good, like a alert message, you guys. Yeah, it would be. You left it in for breathe. Okay. All right. So now what happens is that your two values up top aren't happy. Do you agree?
Agree.
I'm going to send them down. Just rewrite this as 1 over x to the 3/2, x to the 3/2, y to the 3rd, and then y to the 9/4. All I'm doing is just taking an extra second to rewrite them through. Am I right with that? I'm just bringing them down. I'm sorry, what's that? Now I'm going to work on combining them. So if I'm looking at the variables of x, I have the same base, different exponents, so I have to add my exponents together. What's 3/2 plus 3/2? 6/2, which is 3. So it becomes 1 over x cubed. All right with that?
Yes.
All right.
And then
1/3 and 9/4. We have to get the common denominator. It's a 12th, so it's not that bad. That becomes what? 4/3, and then, oh, sorry, 4 over 12, and then that would be 27. Thank you. So it becomes y to the 31 over 12. No. Because you have a fractional exponent in the denominator, which you have to rationalize through.
Oh my God.
There's a couple of things you can do here.
Combine 12.
Nobody. Nobody. That's right. It's kind of bummed by that.
maybe I got it right.
There's a lot, I'll tell you one thing, there was a lot of frowny faces drawn on it though. Maybe 1 or 2 middle fingers drawn on it. I don't know.
Really?
Is it like-
Really?
No. Wait, Mr. Murphy, are we gonna get these cookies back?
Yeah, I'm gonna take that. Now, at this point,
I got a 8.
just like a quick little subset here. This is, what is it? The 12th root of y to the 31st. Do you agree?
Yeah.
All right. If I simplify that,
Oh.
12 goes into 31 how many times?
Twice.
Twice. How many are left over?
7.
7. So this is y squared, and then, what is that? And then 7, y to the 7/12. You okay with that?
Yeah.
I'm rewriting this. Y squared times y to the 7/12. All I did was simplify out the fractional exponent of 31 over 12 and do it this way. Yeah. Now in this case, I've got to get rid of that fractional exponent from the denominator because it's rationalizing if you think of it that way. All right? We didn't want to leave a square root in the denominator. We needed to create that into a whole. How many do I have to add to it to turn it into a 12? 5. So I'm going to multiply top and bottom by y to the 5/12. Okay? Which therefore creates this value, 7/12 plus 5/12 is 12/12, which is 1. Yeah.
Like
So-
literally just one?
Y to the
or
one, Y to the one, yeah.
So then it's Y on 3.
Correct.
Alright.
So the denominator now becomes x cubed, y cubed, numerator's y, 5, 12. I don't hate it. I really don't.
Wait, was this curve or something?
You had to
No, I took like one off it unless you skipped it. Yes, ma'am.
So it's like y cubed over y because you have y squared.
I was kind of cool.
Correct. Yep. Because I'm creating this is creating y to the first power right here. Okay? I'm creating a factor of 1. Okay? Now, the rest of it was pretty much fine unless you made a bonehead move as far as finding an inverse or whatnot. To be honest with you, the inverse stuff, I don't think there was that much messed up. Remember, when you're finding inverses, it's nothing more than switching x and y and going back. Okay? Let's see what I want to do. I know, but I still have a couple of people that I got one next hour and one after that